Welcome to the DIY Honda Garage channel. The DTC B123F indicates an automatic lighting control unit or sunlight sensor error in the Honda Accord, specifically models from 2017 to 2023. This diagnostic trouble code is triggered when the vehicle system detects a malfunction within the automatic lighting control unit, which manages the vehicle's headlight functions based on available light conditions. The sunlight sensor, located on the dashboard near the windshield, plays a vital role in this process by measuring the intensity of sunlight, thus informing the automatic lighting system whether to activate or deactivate the headlights automatically. It's essential to address this error promptly, as it may lead to improper headlight operation and reduced visibility while driving, especially in changing light conditions. Understanding the circuit connections and the role of the components involved in this system will help in accurately diagnosing and repairing the issue. The automatic lighting control unit is a crucial component in modern vehicles like the Honda Accord. It is responsible for managing the headlights based on external light conditions, enabling automatic headlights to function properly. The sunlight sensor is typically located near the top of the dashboard, where it can effectively measure sunlight levels. This sensor detects changes in ambient light, signaling the control unit to adjust the headlights accordingly. Any malfunction in this system can lead to either the headlights failing to turn on in low light conditions or staying on unnecessarily, draining battery life. The circuitry involved includes connections to other vehicle systems, including the climate control unit, ensuring a seamless integration of functions. Thus, inspection and repair are critical to restoring full operational capability of the lighting system. Several possible causes could trigger DTC B123F in the Honda Accord. An open wire in the TSUN line could disrupt the communication between the sunlight sensor and the control unit. If the sunlight sensor itself is faulty, it may provide inaccurate readings or fail completely, directly affecting the automatic lighting system's performance. Additionally, a malfunctioning climate control unit, which works closely with the lighting control functions, could also be behind this error code. Lastly, shorted wires in crucial circuits can lead to interruptions in the electrical pathways, causing system malfunctions. Thorough diagnostics will reveal the root cause and guide the necessary repairs to ensure reliable performance. Several symptoms may manifest with DTC B123F, indicating an automatic lighting control issue in the Honda Accord. Drivers may notice that the headlights fail to adjust automatically, remaining either dim or too bright in various lighting conditions. Additionally, warning lights may illuminate on the dashboard, indicating the existence of a fault in the lighting system. Inconsistent lighting performance can occur, making it unsafe to drive at night or in low light conditions. Flickering lights may also be observed, signifying electrical issues within the circuits linked to the automatic lighting control unit. Addressing these symptoms promptly is essential, not only for safety reasons, but also for the overall functionality of the vehicle. The first step in troubleshooting DTC B123F requires verification of the problem. Start by using the HDS or Honda Diagnostic System to clear the diagnostic trouble codes present in the vehicle. This step resets the system and allows for fresh diagnostics. Next, turn the vehicle to the off-lock mode, ensuring that all systems are inactive. After waiting a moment, turn the vehicle back on. Following this, initiate the self-diagnostic function using the HDS or the climate control unit, which checks for existing DTCs. This initial verification will help determine if the error is a persistent issue or a possible intermittent fault. It sets the groundwork for further investigation. In the second troubleshooting step, it's essential to confirm the presence of an automatic lighting system in the vehicle. First, set the vehicle to off, lock mode. Once this is done, examine the combination light switch to see if it has an auto position. This position indicates that the vehicle is equipped with an automatic lighting feature. If the switch does possess this position, proceed to the next step to dig deeper into the underlying issue. If not, proceed to during step 3 of the troubleshooting process. Check for the presence of an automatic wiper system. This is similar to the previous step regarding the lighting system, as these two features often function together. Begin by confirming the wiper washer switch to see if it has an auto position. This feature indicates the vehicle's wiper system can automatically adjust to rain conditions. If the wiper switch has this auto position, move on to the next step to continue diagnostics. However, if it does not possess the auto feature, proceed to step 9, indicating that the automatic settings may not apply, and alternate issues regarding the DTC must be investigated. Step 4 entails performing a crucial check for continuity in the T-Sun line, which is essential for the communication between the climate control unit and the sunlight sensor. Begin by disconnecting the relevant connectors, the climate control unit connector A, 32P, and the sunlight sensor 2P connector. With these disconnected, you will check for continuity between the specified test points. Ensure the vehicle is in off-lock mode to obtain accurate readings. Test point 1 will be on climate control unit connector A, 32P, number 10, and test point 2 will be on the sunlight sensor 2P connector, female terminal, number 2. If continuity exists, it confirms the T-Sun wire is intact. If not, follow up with the necessary repairs by addressing any open circuits present. At this stage in troubleshooting, you will check the continuity of the sensor COM line, a critical pathway that allows for communication between components. As with the previous steps, the vehicle should be in off-lock mode, while both the climate control unit connector A, 32P, and sunlight sensor 2P connector remain disconnected. Proceed to check continuity between two specified points. Test point 1 is climate control unit connector A, 32P, number 12, while test point 2 is on the sunlight sensor 2P connector, female terminal, number 1. This test will confirm if the sensor COM wire is functioning as expected. If continuity is confirmed, proceed to the next troubleshooting step. If not, repairs are needed to address any open circuits found within this wire. In this step, you will conduct a shorted wire check for the T-Sun line to ensure it has not been compromised. Begin by confirming that the vehicle is in the off-lock mode and that both the climate control unit connector A, 32P, and sunlight sensor 2P connector are disconnected. You will then assess continuity between test point 1, which is on climate control unit connector A, 32P, number 10, and test point 2, which you will connect to the body ground. The goal here is to check for any continuity revealing a potential short to ground within the T-Sun wire. If continuity is present, it suggests the wire is shorted and will need repair. If not, this indicates the T-Sun wire is intact, and you should then proceed to the next troubleshooting step. Proceeding to step 7, this troubleshooting task involves checking for shorts between the T-Sun line and the sensor COM line. As always, ensure that the vehicle is in off-lock mode, with both the climate control unit connector A, 32P, and sunlight sensor 2P connector disconnected. The focus is on continuity between test point 1, placed at climate control unit connector A, 32P, number 10, and test point 2, found at climate control unit connector A32P, number 12. If continuity is detected, it indicates there is a short between these two wires, necessitating immediate repair of the short. Conversely, if no continuity is evident, It confirms that both the T-SUN and sensor COM wires are functioning correctly, allowing you to move on to the next diagnostic step. In troubleshooting step 8, you will reconnect the previously disconnected connectors to evaluate the functionality of the sunlight sensor. This includes reconnecting both the climate control unit connector A, 32P, and the sunlight sensor 2P connector. After ensuring all connections are secure, conduct a test on the sunlight sensor to determine if it operates as intended. If the sensor passes all tests, it indicates that the climate control unit may need replacement. However, if the sensor does not work correctly, it suggests that the sunlight sensor itself is faulty and should be replaced to resolve the issue. This assessment plays a significant role in pinpointing which component requires action to restore normal system performance. During step 9, it becomes crucial to examine fuse number A27 as part of the troubleshooting process for DTC B123F. Start by checking the integrity of this specific fuse within the vehicle's electrical system. If the fuse is operational, proceed to the next step with diagnostics. However, if the fuse is blown or damaged, it needs immediate replacement. After replacement, it is essential to recheck the fuse's performance. If it blows again, this indicates a deeper electrical fault, likely requiring the investigation of a short within the fuse circuit. This step is important in maintaining the integrity of the vehicle's electrical functions and should not be overlooked during troubleshooting. Step 10 focuses on determining potential failure areas, particularly concerning the BCAN lines and other components. Start by disconnecting the automatic lighting control unit sensor 5P connector. Once disconnected, measure the voltage between test points 1 and 2 while ensuring that the vehicle remains in off-lock mode. Test point 1 will be at automatic lighting control unit sensor 5P connector, number 3, while test point 2 will be at number 4. The purpose of this test is to confirm the availability of battery voltage. If voltage is present, it implies that power reaches the sensor adequately. If not, further investigation is necessary to identify possible faults in the power delivery system that could affect functionality. Pinpointing issues at this stage is critical to ensure system reliability. As you advance to step 11, you will perform an open wire check specifically for the BCAN H line. Start by disconnecting the climate control unit connector A, 32P. Continuing in off-lock mode, assess the continuity between two pivotal test points. Test point 1 will be the automatic lighting control unit sensor 5P connector number 1, and test point 2 will be climate control unit connector A, 32P number 25. This continuity check is essential to ensure that the BCAN H wire is intact. If continuity exists, it indicates that the wiring is unharmed and you can move on to the next step. Otherwise, you must repair any open circuits found, as they may be causing the DTC and leading to failures in the communication between control modules. In troubleshooting step 12, the goal is to conduct an open wire check on the BCAN L line to confirm its functionality. Similar to previous checks, ensure the vehicle is in the off-lock mode while both the automatic lighting control unit sensor 5P connector and the climate control unit connector A, 32P, are disconnected. Assess the continuity through a connection from test point 1, located on the automatic lighting control unit sensor 5P connector number 2, to test point 2 at climate control unit connector A, 32P number 8. It's essential to verify that the BCAN L wire is operational and intact. A successful continuity check confirms the wire is functioning correctly, while a failure indicates a need for repair to address any openings in the circuit that may be leading to communication issues. As you reach step 13, you will reconnect the relevant connectors to finalize the diagnostics process. Take care to reconnect both the automatic lighting control unit sensor 5P connector and the climate control unit connector A 32P. Once reconnected, use the HDS to clear any existing diagnostic trouble codes. After clearing the DTCs, switch the vehicle to off lock mode and then back to on, ensuring the system is ready to complete testing. Allow at least 8 seconds before conducting the self-diagnostic function once again using the climate control unit. Finally, check for DTCs to see if the original error DTC B123F or any new codes have emerged. This step confirms whether the issue has been resolved or if further repairs are warranted. In the final step of the troubleshooting process, focus on checking the +B backup line for potential issues that may affect system operation. Measure the voltage between test points 1 and 2, ensuring the vehicle remains in off-lock mode, while the automatic lighting control unit sensor 5P connector is disconnected. Test point 1 will be at connector number 4, while the second point should be connected to body ground. If battery voltage is present, this indicates proper power availability, and further diagnostics should assess any open in the ground wire. If no voltage is detected, repair any openings found in the +B backup wire to restore functionality. This final step is significant, ensuring that all electrical connections are verified, maintaining the automatic lighting system's reliability. The final repair verification step is crucial to ensure that all identified issues linked to DTC B123F have been effectively resolved. After performing any necessary repairs based on the previous troubleshooting steps, conduct file checks to confirm the functionality of the automatic lighting control system. This includes verifying each component, such as the sunlight sensor and climate control unit, is operating correctly. Utilize the HDS to run diagnostic checks and confirm that DTC B123F no longer appears. This step is vital in ensuring that the vehicle's automatic lighting adjustments and functionality are restored, providing confidence to the driver that their system is reliable. For effective preventive maintenance regarding the automatic lighting control system in the Honda Accord, regular inspections of all associated electrical connections is essential. Keep an eye on the condition of wiring and connectors, ensuring they remain free from corrosion, fractures, or any signs of wear. Periodically testing the functionality of the sunlight sensor and climate control unit can help catch potential issues before they lead to system malfunctions. Ensuring that software updates are applied via the HDS can also prevent communication errors from causing trouble codes like DTC B123F to appear. Staying vigilant in maintenance will extend the lifespan of the components involved and ensure the automatic lighting system operates reliably under various driving conditions. In conclusion, addressing DTC B123F related to the automatic lighting control unit and sunlight sensor error requires a systematic approach. Utilizing the detailed troubleshooting steps outlined allows for the accurate identification of the root cause and successful repairs. Essential components, including the T-Sun line, sensor comm line, and associated wiring, should be thoroughly evaluated during diagnostics. Regular maintenance and periodic checks on sensor functionality play a vital role in preventing errors. Prompt attention to this DTC not only ensures the safety and performance of the vehicle during varying light conditions, but also reinforces the integrity and reliability of the vehicle's systems overall. By staying proactive, drivers can enjoy a smoother, more dependable driving experience. Please like and subscribe to the channel. See you next time!